Well, we had a look at capacitors in parallel. Now we're going to have a look at capacitors in series. We're using the same values that we used before. We've got 10 microfarad and 100 microfarad. And for the three combination, we've got 10, 100 and 100, the same as we used before. I've written down the values here just as they were measured a few minutes ago. So the 10 microfarad is actually reading 8.3. One of the 100 microfarads is reading 82, and the other one is reading 81, and we'll look at that a bit closer in a minute. If we put two capacitors in series like this, what you've done is increase the distance between the plates as is shown here. And if you remember the formula, you can see that the distance between the plates is on the bottom, of the formula. So if that distance increases here, then it's going to have an effect on the overall capacitance and reduce it. So that's how it basically works. So if we look at the capacitors, the two capacitors in series here, you can see that we're just using the product over the sum equation. And you can see here I've got 10 microfarad times 100 microfarad divided by 10 microfarad plus 100 microfarad, the same as you do with a parallel resistance. And we ended up with 9.1 microfarad. And that being less than the smallest value would give a general indication that you're in the right ballpark. Now if I put the proper figures in, the 10 microfarad reading 8.3, the 100 reading 82, I end up with 7.54 microfarad. So what I've done here is put the two capacitors in series, and as you can see here, again we're using the same electrolytics that we were using before, one reading one end, one reading the other end, on the probes. And our calculation that we had before was about 7.54 microfarad. And you can see here that our reading that we're getting at the moment is 7.51 basically. So we're pretty much on the ball with reference to our calculation for the values that were measured of each of these capacitors. So what I've done here is just redrawn the calculations just to have a closer look at them. And as you can see here, on the left hand side we've got the ideal values, which is the 10, 100 and 100. And when you do all the calculations, you come down to these figures here and we end up with basically 8.3 microfarad. Now you can see up here I've put in the ideal and the actual measured. And in the green area here we're using the measured values, and you can see there that going through the calculations we end up with 6.896 microfarad. And what we'll do now is just go over to the bench and we'll look at that in real time and see if we end up with this value here. So what we have here are the three electrolytic capacitors. You can see here we've got one in series with the next one, in series with the next one. We've got all the negatives to one side and obviously the positives are to the opposite side. And we'll put the meter on now and we'll see what our effective capacitance is now. Alright, so we've attached the meter to the three capacitors in series, and you can see here that we're getting an overall reading of 6.8 microfarad, or close to 6.9 microfarad. You've got to keep in mind that when you're using these breadboards, you're also getting effects with reference to plugging into the breadboard by each of the capacitors, etc. So you will get a slight difference, but the point is it's pretty much close to where we should be with the calculations.